Hello students. So now let's take a look at some examples. This time round we are looking at inequalities, right? So what about inequalities? Now inequalities, they are also mathematical statements that are sometimes true, sometimes false, depending on the value of the unknown, right? So just like equations, we can actually solve them. So how do we go about solving them? In this case, the solution will not be a single value, but rather a range of values, because that's what inequalities give us, right? So let's take a look at the first statement. We have x plus 1 is less than 24. So if we were to follow the idea, let me change the color of my pen, right? That means x is going to be less than 23. All I need to do is actually to subtract -1 on both sides of the inequality, and that will work. Now the main thing to take note for inequality is that when we multiply or divide by a negative number, the direction of the inequality actually changes. Otherwise, they function quite like the equation. Yeah? So after we have obtained the solution x less than 23, which means as long as x is less than 23, the original statement is going to be true. Now they want us to, of course, illustrate the solution on a number line. We can do that. So let's draw the number line. Right, this is the number line. The values on it, we have 23. Right, so 0 is somewhere here. That means the number line will look like this. Okay, so what does the open circle like this means? It means that the value is not equal to 23. It has to be strictly less than 23. If it can be 23, it will be a closed circle. Right, so let's take a look at the next example. So next example, we have x minus 3 is less than 17. So x is going to be less than 20. We just need to add 3 on both sides. So similarly, if we draw the number line, right, we will have 0 here, 20 here, and again it's less than. So that's how we can illustrate it. Okay, next example. This time round, we're going to divide both sides by 3. So x is going to be less than 8. Right, so very quickly, this is how the number line will look like. We have 8, and then we have 0. So this looks like this. Right, now next example is where we're going to be careful. Right, when we divide by -3, we have x on this side. 24 divided by -3 is actually -8. However, because we divide by a negative number, the direction of the inequality actually changes. So x is actually greater than -8. So if it's greater than, how does the number line look like? We have -8 here, we have a 0 here. So it goes to the right side. Greater than, it goes to the right side. Right? Now next example, what happens with decimal? Well, with decimal, in this case, I multiply by 2 on both sides. It's fine, it looks like this. Direction did not change just because it's multiplication, right? It's only when it's negative. That's why you got to be careful. So we have 0, 32. It's going to be less than 32, so it looks like this. Okay. Now, here's another example where the coefficient in front of the x, right, is actually the negative. Therefore, what we did here is we multiply by -2 on both sides. So since it's negative number that we're multiplying by, the direction actually changes. So now my number line will look like this. We have -32, 0. This time round it goes to the other direction. Okay. So with this, you can actually pause the video, try the rest of the exercises here, and then unpause the video and compare answers with what I'm going to write down in the following questions. So I hope you are successful. Let's go. Let's begin. Right, in this case, I'll just have to divide both sides by 6. So we will have -8. So my number line will look like this, right? We will have -8, 0 here. So it will be greater than, it goes in this direction. Example B, this time round, I just multiply by 3 to get 18, then divide by 2 to get 9, right? So let's go. We will have this situation. 0 is here, 9 is here, maybe we have something like 18 is here, right? So this time round it can be equal to 9, so I'm going to color it, and then it goes this way. Okay. Next, how about this situation? Well, this situation I can always make the denominator the common, right? So this works quite well. That means 3x is less than or equals to 12, x is less than or equals to 4. So from here, once again, we will have 4, 0, and here we go. It's just like that. Okay. Another situation where the denominator can be made common quite easily, right? So we do this. It's 9. That will give us 30. Okay. So 5x is greater or equals to negative 30. X greater or equals to negative 6. So that works out. The number line will look like this. We have negative 6, 0 here, greater or equals to negative 6. There we go. Right, let's go on. Now, what happens when we have this scenario? Okay, there are a few ways we can do this. We can, of course, divide by 2 on throughout, or we can just expand, right? It works either way. Sorry, let's try this again. So we have 4 plus 2x is greater than negative 13. That means 2x is greater than negative 17. X is greater than negative 8.5. Okay. So my number line, negative 8.5, 0 is somewhere here, strictly in this direction. Okay. One more example. Okay, similarly, I can expand, right? Equal to negative 3x minus 3. This is fine. Now, when add or subtract, it doesn't really matter. The direction do not have to change. We only change the direction when we try to add or subtract when we try to multiply or divide by a negative number. Adding and subtract doesn't affect the direction of the inequality. So this gives us 5x greater or equals to negative 10, and x is greater or equals to negative 2. So how does my number line look like? Negative 2, 0 can be equals. So I color it and it looks like this. Okay? So I hope you've been successful. Let's move on to the next page. Now in the next page, okay, the question this time around asks us to find the greatest integer of x that satisfy each of these inequality. Right, so of course the first thing we need to do is to solve the inequality. So in this case, what can I do? Well, let's rewrite it in this manner so that it is cleaner. Then of course I can make the denominator common. In this case is 3x over 6 plus 2x over 6. And on this side, if I want to, I can always do this, right? So from here, we have 5x is greater than negative 60. X is greater than negative 12. Right? So we are not quite done, right? We are not quite done. Because this is an inequality, the question actually asks for a single greatest integer, right? So therefore, we need to write down, therefore, greatest integer x is actually equals to, well, what is it? It is going to be negative 11, right? I mean, if you need to get some confirmation, you realize that negative 12 is here, 0 is here, so we move here, right? So it looks like this. 11 is going to be somewhere here. Okay? So, sorry, negative 11, right? So same idea here, the greatest okay, there's an error in the question over here, right? So let's correct this. This one should be the smallest. Okay? So it's the smallest because the greatest in this case is actually infinity, right? So there's an error in the question. So this one is the greatest, right? So same idea. This is 2y over 3 plus y over 4 less than 7. Now what I can do here is I can multiply by 12 throughout. So that will give us 8y plus 3y is going to be 84. Okay? So 11y less than 84. Y is less than 7 and 7 over 11. Okay? So we look at the number line, right? 7 and 7 of 11, so somewhere here. So greater this way, right? So somewhere here is 7. Therefore, greatest. Let me go back here. This is the smallest. Okay. Right, the greatest integer. Oops, my handwriting is terrible. Let's try again. Integer y is equals to, in this case, 7. Okay. So that's what we need to take note. Read the question carefully. If the question is asking for a particular integer, we actually need to answer the question exactly, one single answer, although the solution to inequality is actually a range. Okay, now let us look at the last part over here, problem solving involving inequalities. So over here, we need to consider the context, right, and give a complete and accurate range. So what do I mean? Here, Billy and Carol decide to buy a present for their parents' wedding anniversary. Billy has agreed to pay $40 more than Carol, and then the present they are buying together is to cost not more than 180. So you need to actually translate this properly, right? So form an inequality and solve it to find the possible amount Billy has to pay. Let the amount that Carol has to pay be X. So what we're going to begin with is to write down the amount Billy has to pay, right? Amount Billy has to pay is equals to, now Billy is going to pay $40 more. So Billy is probably the elder siblings who has more income or more pocket money, right? So therefore, total amount is equals to x plus 40, right? Which is equals to 2x plus 40. Okay, so this is the amount, right? Okay, so from here we now need to form the inequality. So 2x plus 40 is going to be less than, can it be equals to? Well, the answer is yes, right? Because 180 is not more than 180. Hear that again, 180 is not more than 180. So it's lesser than or equal. Now, if you want to be more complete and thorough, okay, they're going to buy a present, right? Though the present could be free. Who knows, right? It's possible. Okay. So if we work out this way, what happened is 2x. Can the present actually be free? No, if you do that, then x become negative, right? So if Billy actually pays $40 more than Carol, if Carol doesn't pay anything, then Billy actually pays 40, which means the present is at least 40. Okay, so that's what we figured out. So from here, this is 0, this is 140, right? So x is between 0 to 70. Okay. So there is the amount. So we want to find the possible value Billy has to pay, right? So let's see. We have to add. This is Carol. X is Carol. So we actually need to find x plus 40, right? So x plus 40 is between 40 to 110. Okay. So therefore, possible amount Billy has to pay is between $40 and $110, and because it can be equals, so we need to add the word inclusive, right? So that's the amount. Okay, right? Is there any more example? Yes, let's go. Next example. Next example, we have a fruit seller bought a case of 136 oranges for $25.40. If he sells each orange for 35 cents, he aims to make a profit of at least $8. Form an inequality and solve it. So let's go. Part A. X is the number of oranges. Therefore, right? We have $0.35, which is the same as 35 cents, times the number of orange, right? Minus away the amount that he paid for it, which is 25.40. Okay, and that should be more than $8 because this is a profit, right? The profit is the total selling price minus the total cost price. So from here, we work this one out. We can actually find the range of values for x. Okay, so we have 0.35x is greater or equals to 33.4. That means x is greater or equals to 95/3/7. Now x is the number of oranges. It should be a whole number. So the next integer after this is actually 96, right? So therefore, okay, number of oranges let's spell it correctly. He must sell is at least 96. That's the number of oranges you must sell. Okay, so that's part A. Part B, hence state the least number you must sell, right? So part B, least number of oranges. Okay, fine. Possible, sorry, yeah. Let's rewind a little bit, because what I did was to actually answer part B in part A. Okay, so this is actually the answer for part B, right? So part A actually asks for the possible number. So possible number of oranges. Oranges he must sell is between 96 and 136 inclusive. Least number of oranges. Oh, I can't spell oranges. Let's try. Oranges equals 96. Right, let's move on. Next one, water at 24 degrees Celsius point to a boiler. The temperature of the water in boilers increases by 7 degrees Celsius per minute. Find the time range, right? So take note, we're looking at the range for which the temperature of the water in the boiler is greater than 52 but not greater than 73, and the time is x, right? Time range is x. Okay, so let's take a look. Temperature, okay, what is the temperature? The temperature is actually, it starts from 24 degrees and every x minute, right, include a 7. So this is actually the temperature. Okay, so what we want to find is we want 24.7x to be in between 52 degrees Celsius as well as 73. Now, is it equal to 73? Is 73 greater than 73? No, it is not. So 73 is not greater than 73. That means, can it be? It can be 73, right? Right? Because if 73 is still not greater than, so this is fine. How about 52? Has to be greater than 52. So this is the range. So from here we work it out. 7x is going to be in between 28 and 49. Just subtract 24 throughout. So x is in between 4 and 7. Okay. So now we got to write the statement quite differently. Okay. The time range, right? The time range is greater than 4 minutes but not more than, let's cancel this, than 7 minutes. There we go. That's the solution. Okay. Right, next example. I guess it's the final one. A rectangular box is 2x minus 1 cm long and x plus 3 cm wide. If the perimeter is greater than 38 and not greater than 80, find the range of possible value. So let's find the perimeter first. Perimeter is equals to 2x minus 1 plus x plus 3 plus 2x minus 1 plus x plus 3, right? So that gives us 6x plus 4. Now that means that 6x plus 4 is greater than 38, not greater than 80, but we can still put 80, right? Because 80 is not greater than 80. So we work this out. 6x, so you minus 4, 34, 76. So x is going to be in between 5 and 2/3, as well as 12 and 2/3. And that is already the possible range of x. Okay, so that's how we can work it out. I hope you have some success. Once you understood how this thing works, go ahead and try the assignment that has been given to you. All the best.